Welcome to the fourth video in this series of Python Cookbook. We will today be looking into chapter 1's 1.8. Now, this section of the chapter looks into calculating with dictionaries. Now, we want to perform various types of calculations in, for example, finding a minimum value or the maximum value or sorting the dictionary. In that dictionary data. Now, considering a dictionary is a map of sorts. For example, like if we look at Acme, in this example, we have a shares and their prices for each company. For the first share of ACME, the share price is 45.23, and the share for Apple, the price is $612.78. For IBM, it's $205.55. HPQ has a worth of 37.20, and Facebook has a dollar worth of 10.75. Now, we want to find the which share has the highest value or which has the highest price, or we want to find how which one is the minimum value. We could easily find that out by looking in this chart, but the computer doesn't know that. So the computer needs to go through a very set of codes, and we need to give it instructions on how to find the maximum value or the minimum value. So in order to perform these calculations in these dictionaries, we would use a function called zip. It is often useful to invert the keys and values while using this dictionary of zip. For example, here we would want to find the minimum or maximum price of a stock and the name of that stock. So for this, we would have a minimum price. We would use the min function that we have already discussed beforehand in another lecture. We would use the zip function to zip the prices dot values and prices dot keys. Now, in the previous slide, the keys are the names of these shares and the prices are the values. So when we zip the values and its keys into a minimum, what the zip function does is it iterates the whole dictionary, then finds it goes over the whole dictionary, and what min does is that min finds the minimum value in that dictionary. The same goes for that max function in the third line. Over here, zip helps iterate over the whole dictionary, and max just finds the maximum value, not the key, but the value in that share. Similarly, if we want to, let's say, uh, rank the data using zip with sorted function, we would use the code something like prices sorted is sorted, and again we would use the zip function to iterate over the whole dictionary, and it would sort over every single share and its prices based on the prices, not the name again. When we are doing these sorts of calculations, we have to be aware of what type of iteration that zip makes. Uh, the zip only goes over the function once. For example, if we have a price and names and zipping the price of values and price of keys, we could only get the min or the max. But if we want to use the price and names, it would throw an error. Now, let's say you have two different dictionaries and you want to find what values are values or keys are similar in those two dictionaries. For example, you have a dictionary A and dictionary B, where A consists of X, Y, and Z, where x has a value of 1, y has a value of 2, and z has a value of 3. Now, if you look at B dictionary, B has w, x, y, and w has 10x is equal to 11 and y is 2. If we can, if we see at the dictionaries, we can see that x and y are in A and B, both of the dictionaries, while x has a different value in B. In dictionary A, x's value is 1, while in dictionary B, x's value is 11. But in both cases, the value for y key is the same, which is 2. Now, we want to find how would we find the common in these dictionaries, in two of these dictionaries. Now, if we want to look for the common items to find which items and or keys are common in both of the dictionaries, we would simply write a dot keys and b dot keys. What that AND function does is it would show us which keys are similar in dictionary A and dictionary B. Now, what about we want, or what if we want to find which item is not common in dictionary A and dictionary B? We would simply write A dot keys minus B dot keys, and it would give us Z. Now, one question that might pop into head is that uh, in dictionary B, there's W, and it's not common in A. Then why, when we are trying to find a unique one, it only shows the Z, which is only available in A, and why not it's showing the unique item that's in B, which is W? Well, if we reverse this, if we write B dot keys minus A dot keys, it would show W instead of Z. So it really depends on which dictionary you're writing at first, then which dictionary you're minusing it from. Now, what if we want to find which keys and values are similar or common in both the dictionaries? What I mean is that we want to find from A and B is we want to find Y, which has the same key and same value for both of the dictionaries. Okay, we would just simply write A dot items and B dot items. Instead of when we first wrote A dot keys and B dot keys, we would just simply write A dot items and B dot items. This would give us both the key and the value, which is Y and 2. Now, this kind of operations can also be used to alter or filter dictionary contents. So, for example, if suppose you want to make a dictionary with, you want to remove something from the dictionary. Now, the code for that would be like C is equal to key, which would be the A of key for keys in A keys. Which what that means is that we want to find which keys are which keys are not in Z and W, which would simply give us C is X1 and Y2. We are just simply minusing Z and W from A dictionary. Now, we want to look at and want to remove duplicates from sequence while maintaining the order of that sequence. Now, what that means is that we want to eliminate the duplicate values in a sequence, but preserve the order of the remaining items. What that means is that, let's say, look at this example, 152191510, but we want to remove A. Like we want to depute A. So what depute means is that we're creating a function which is depute and it takes items. So in scene is equal to set of items for items in item for item in items. If item not in C, which is a different set, it would yield that item. So that uncommon item would be out of the list, and we would add that item in scene instead. So basically what this code does is that it would remove that item from list and it would add that same item into the scene set. Now, if we do this code, look at this code, we have 15 A is equal to 1521915 10, and we want to depute. We're forwarding this a list into depute function. Now what this function does is that it would remove the items that were duplicate in that list. Now if we look at the list, we could see that one has been repeated once, five has been repeated, and every other one is only written once. One is written three times and five is written twice. Other than that, 2, 9, and 10 is only written once. So when we use that depute function, we would get 1, 5, 2, 9, 10, which easily removes all the other duplicate values in that list. Now, this only works if the items in the sequences are hashable. What hashable means is that it's part of a hash map. Hash map is a type of data structure that I believe you guys would have studied in Python basics. Now, if you are trying to eliminate the duplicates in that sequence of hashable types, such as dictionaries, you can make slight changes to the recipe or slight changes to the code. Now, what kind of changes? You could see that for the depute function, we are still taking in an item, but at, we are also taking in a key which we're making it none. Now, scene is still a set, but for items, in items, we are using the value item if key is not none else than the key of item. If val or the value not seen in scene, then we would get that item out of that, and then we will add the scene. Scene is the set of numbers that are unique, that are not being repeated. Now, for the purpose of the key argument is to specify a function that would convert a sequence of items into a hashable type. For the purpose of duplicate detections, we are using an hashable type. Here's how it works. Like A is an array that that stores in multiple lists in itself, uh, which lists consist of maps or dictionaries, where the first list is x is 1, y is 2, the second list is again x is 1 and but y is 3. Now x in the third list is x is 1, y is 2, and x is 2 and y is 4 for the last list. Now if we use the depute function as we did before, it would remove all the dictionaries that are that are the actually the same dictionary that has been repeated. If we look at the first dictionary, which is x1 and y2, we could see that the third dictionary also listed the same values and the same keys. For x1 and y2, the third dictionary also has x1 and y2. Now, when we pass through that array through the depute function with the key lambda, you guys would have learned about lambda. Uh, it shows that the values of the unique lists that are within A, which is x1, y2, x1, y3, and lastly x2, y4. Now, if we want to go even further into dismissing the duplicate values, for example, in the third line, you could see that x1, y2, and x1, y3, there are x's repeated with the same value. So if we want to go even deeper into removing duplicate values, we could just simply uh, put forward the A array through the depute function, but while adding a key lambda of dx. So we're looking into the x value. So what this does is that it would remove any value where x's number was repeated, x's value was repeated, and it would only keep the one that was given at the very beginning, or it has the higher order. So here we could see that x of 1 and y of 2 is still remaining in the array, while x of 1 and y of 3 is no longer part of the array. And lastly, x of 2 and y of 4 is still part of the array, since it has nothing in common with the other two, especially the value of x, which is the main focus of this function. Uh, The latest solution would also work nicely if we want to eliminate duplicates of values based on value of a single field or an attribute, or we want to remove those data from a larger data structure. These types of functions and this types of depute uh, removing duplicates of sequences come in handy when the data that we're working with is huge for us to handle it manually. So we would do those types of functions, do those types of codes when we want to automate these types of removing of data from a data structure, from a database. And that is all for this video. We have looked through from 1.8 to 1.10. Next, we will be looking from 1.11 to hopefully 1.15. That's all for this video, and thank you for watching. Hope to see you in the next one. Thank you.